March 27th, 1989. A room full of Soviet engineers on the Crimean Peninsula is waiting for a signal that is already late. 400 million kilometers away, in orbit around Mars, their spacecraft has just done something routine. It has turned to photograph one of Mars's 2 small moons, and to aim its cameras, it had to swing its antenna away from the Earth and go quiet. The engineers expected that. They know, almost to the minute, when the signal should return. The minute comes, the signal doesn't. About 4 hours later, something finally arrives, but it's wrong. The kind of garbled pulse a spacecraft sends when it is no longer pointed at anything at all. When it is tumbling, that is the last thing anyone on Earth ever hears from the probe. It had crossed the entire solar system to reach Mars, and to slip closer to one of its moons than any machine ever had. And in its final minutes, circling the red planet, it took a photograph. What that photograph showed, and what made the spacecraft fall silent at the exact moment it turned to look, became one of the strangest, most disputed stories in the history of spaceflight. A story the Soviet Union, for a long time, chose not to tell. So let's find out what was actually out there. The spacecraft was called Phobos 2, and it carries a quiet distinction that most people don't know about. It was the last interplanetary probe the Soviet Union ever designed. To understand why that matters, you have to understand how long it had been since the Soviets had tried something like this. After a string of disappointing Mars probes at the start of the 1970s, the political leadership had more or less lost patience with the red planet. The results weren't impressive enough to justify the cost. And so the money dried up. For roughly 15 years, almost no Soviet funding went toward Mars at all. But the scientists never stopped thinking about it. At the Space Research Institute in Moscow, known by its Russian initials IKI, a group of researchers kept turning the problem over in their minds. They knew that if they wanted to go back to Mars, they needed an idea good enough to change the leadership's mind. And by the end of the 70s, they had one. Here was the idea. Don't go to Mars, go to its moons. Mars has 2 of them, and they are tiny. The larger one is called Phobos, the smaller Deimos. And what made Phobos so attractive wasn't just the science, it was the orbit. Phobos circles Mars on a path that a chemically powered spacecraft could actually reach without too much trouble. It was, in a sense, the easy door into the Martian system. And targeting the moon instead of the planet had one more advantage that mattered a great deal in 1980s: geopolitics. It let the Soviets do something the Americans hadn't done, instead of repeating something they had. At the very beginning of 1985, the scientists got their wish. The government approved the mission. The public announcements followed that March. Now here is where the human story begins, and it's the part that explains everything that comes after. The man running the Space Research Institute at the time was a physicist named Roald Sagdiv. His institute had just pulled off something extraordinary: the Vega missions, an international effort that had sent Soviet probes past Venus and on toward Halley's Comet in 1986. It was a triumph, and it had put Sagdiv and his scientists in the spotlight. And, according to Sagdiv himself, that spotlight created a problem. The bosses of the Soviet rocket industry envied the attention the scientists were getting. So when the Phobos project was organized, overall control was handed not to the scientists who had dreamed it up, but back to the Ministry of General Machine Building, the part of the system that built the rockets. In practice, that meant the manufacturer got to dictate terms to the customer. The people who would have to fly the mission no longer fully controlled how it was built. And there was one more pressure, the one that would haunt the whole story. By Sagdiv's institute's own estimate, a project this complex needed 6 or 7 years to do properly. They were given 3.5. Remember that number. It comes back. But for all the rush and all the rivalry, this was also, in another sense, a hopeful project. It arrived at exactly the moment the Soviet Union was beginning to open up to the world. And so the Phobos mission became one of the largest international science efforts the Soviets had ever attempted. Scientists from 14 countries joined in from both sides of the Iron Curtain. Austria, Bulgaria, Hungary, Ireland, Poland, Finland, France, Czechoslovakia, Switzerland, Sweden, the United States, both East and West Germany, and institutions of the European Space Agency all contributed instruments or expertise. A spacecraft built in the closed, secretive Soviet system was now carrying hardware from a dozen foreign labs. That openness went further than anyone expected. In 1987, before either probe had even launched, the Soviets put full-scale models of the Phobos spacecraft on public display at an air and space show in France, a remarkable gesture from a program that had spent decades hiding everything. And in the final days before launch, Western visitors were invited to tour the Baikonur Cosmodrome itself, including an Apollo astronaut and a delegation from the United States Air Force, who watched the giant Proton rockets being prepared. The rockets, for the occasion, were even decorated with advertising. The old reflexes hadn't entirely vanished. Rank-and-file soldiers at the base were still ordered to swap their uniforms for civilian clothes whenever foreigners came through, to disguise the military nature of the site. But the direction was unmistakable. This was the Soviet space program trying to step into the light, which is part of what makes everything that came next so painful. Because Phobos 2 did not fly alone, it had a twin. The plan called for a pair of identical probes, Phobos 1 and Phobos 2, launched a few days apart in July of 1988, both bound for Mars. The idea was redundancy. If one failed, the other would carry the mission. 2 spacecraft, 2 chances. Phobos 1 lifted off first, on the 7th of July, riding a Proton rocket off a launch pad at the Baikonur Cosmodrome. For the first weeks, it behaved beautifully. It made its course correction. It switched on a special instrument, an X-ray telescope built only for this first probe, and it photographed the sun, capturing well over 100 images of the solar corona, even catching a solar flare in the act. And then, on the 2nd of September, during a routine communication session, Phobos 1 simply didn't answer. Here is what happened. And it is, without exaggeration, one of the most quietly devastating facts in the history of spaceflight. A controller on the ground had sent the spacecraft a long string of commands, a routine package, meant to keep the probe behaving itself during an upcoming break in communications. Somewhere in that string of code, a single character was wrong. One missing digit. Let that sit for a second. Not a hardware fault, not a collision, not a cosmic ray frying a circuit. A typo. That missing digit changed the meaning of the command. Instead of doing what it was supposed to do, the code reached into the spacecraft's memory and triggered an old test program, a routine that had been written to check the attitude control system on the ground, and that, because there hadn't been enough time before launch, had never been erased from the spacecraft's memory. The test program ran, and the very last thing that test program did, by design, was switch off the attitude control system. So that is exactly what Phobos 1 did. 11 million kilometers from home, it turned off the system that kept it oriented. With nothing holding it steady, the spacecraft began to drift, nudged slowly off-axis by the faint, constant pressure of the solar wind. And as it drifted, its solar panels turned away from the sun. The power faded, the batteries emptied. There was a faint hope that the probe might tumble back into the light on its own, but the most likely resting position would leave the backs of the panels facing the sun dark and cold and dead. After weeks of trying to wake it, the Soviets gave up. Phobos 1 was declared lost in early November. European astronomers even tried to spot it from a telescope in Chile. They saw nothing. The mission had lost half its fleet before it had even reached Mars. And that single missing digit had done it. which meant everything, the entire return to the red planet, 15 years in the making, now rested on the second probe. So let's talk about what Phobos 2 actually was and what it was supposed to do, because the machine itself is the key to the mystery. Phobos 2 was built on a brand new design. The Soviets called the platform 1F, and it represented a full generation's leap forward from the old Venus probes that had come before. At its heart was a ring-shaped instrument compartment sitting on top of a powerful propulsion unit fed by a cluster of 8 fuel tanks. That propulsion section was such a good design that it would later live on, in modified form, as a rocket stage called Fregat that flies to this day. The main engine could fire many more times than any previous Soviet planetary engine, and the whole vehicle was guaranteed to operate for over 400 days. But the most important part of Phobos 2, for our story, isn't the engine, it's the brain. The spacecraft was controlled by 3 identical onboard computers, and they worked on a principle that sounds almost democratic. For any decision the spacecraft needed to make, the 3 computers would effectively vote. The spacecraft would do whatever at least 2 of the 3 agreed on. The logic was sound. If a stray cosmic ray flipped a bit and made one computer go briefly insane, the other 2 would outvote it. 3 brains, majority rules, no single point of failure. Hold on to that idea. 3 computers. 2 have to agree. We'll need it shortly. Now, getting to Mars was its own puzzle. The Proton rocket and its upper stage weren't quite powerful enough to throw a 6-ton probe directly onto a path to Mars. So the launch only lifted Phobos 2 into a stretched-out orbit around the Earth. From there, the spacecraft had to use its own engine to break free and fling itself toward the red planet. It made its course corrections along the way, adjusting its speed by just a few meters per second, the gentlest of nudges across hundreds of millions of kilometers, and aimed for Mars. The plan, once it arrived, was a slow, patient dance. Phobos 2 would break into a wide, looping orbit around Mars, then gradually tighten and lower that orbit, step by step, until it was circling the planet in step with Phobos itself. From there, it would creep closer to the Moon, eventually flying in formation just 35 kilometers above the surface, close enough to study it in detail, but still at a respectful distance. And then came the part that made this mission unlike anything before it. Once it had mapped the Moon and chosen its spot, Phobos 2 was supposed to descend until it was hovering just 50 meters above the surface of Phobos, not landing hovering. Because landing on Phobos is almost impossible. The Moon is so small that its gravity is feeble, barely there at all. Touch down too hard and you don't crash. You bounce and float away into space. So the spacecraft would hang there, 50 meters up, for 15 or 20 minutes, and use one of the strangest instruments ever flown. It was a laser called Lima D. The plan was to fire that laser at the surface of the Moon, vaporizing a tiny puff of soil into a cloud of glowing particles, and then read the light from that cloud to work out exactly what Phobos is made of, which chemical elements, in which proportions. It was a way to taste a moon without ever touching it. And then, finally, it would release its landers. One of them, on Phobos 2, was a little machine that couldn't drive or roll because wheels are useless in that kind of gravity. Instead, it was built to hop, springing across the surface on spring-loaded legs. To keep the other lander from drifting away after it set down, the design called for it to fire a harpoon into the ground, like a tiny anchor, and hold itself down to a moon that barely wanted to hold anything at all. That was the mission. Hover over an alien moon, shoot it with a laser, and harpoon a robot to its surface. And listening for every word of it, back on Earth, was a network that had been rebuilt specifically for this. To talk to a spacecraft as far away as Mars, the Soviets had upgraded their deep space tracking stations, one on the Crimean Peninsula at Evpatoria and a new one constructed in the Siberian town of Ussuriisk. These stations were fitted with powerful new equipment capable of pulling telemetry out of the void at over 100 kilobits per second, from distances stretching as far as 400 million kilometers. They could measure the spacecraft's velocity to within half a meter per second, and its distance to within 10 meters, across all of that emptiness. This was not a primitive operation. For its time, it was extraordinarily precise. And the landers were just as ambitious. Beyond the little hopping probe, Phobos 2 carried a second, longer-lived station designed to settle onto the surface and stay there. Once anchored by its harpoon, it was meant to unfold an antenna some 20 meters long for a ground-penetrating radar, switch on a small television camera to photograph its own landing site, and survive on the moon for as long as a year, long enough to listen, with a seismometer, for the faint tremors that would reveal what Phobos is made of on the inside. It was a serious attempt to turn a potato-shaped rock into a place we actually understood. Now notice one quiet detail in all of this. To point its cameras and instruments at Phobos, the spacecraft had to turn its body, and turning its body meant swinging its main antenna away from the Earth. Every close look at the moon required the probe to stop looking at home. It had done it before, more than once, without trouble. Just file that away for now. Phobos 2 left Earth on the 12th of July, 1988, 5 days behind its doomed twin. And almost immediately, it began to show its age, or rather, the rush it had been built in. Remember the 3.5 years? Remember the 6 or 7 that the scientists said they needed? This is where that shortfall starts to bite. During the long cruise to Mars, things began to fail. By the time Phobos 2 reached Martian orbit, the situation with its 3-computer brain had quietly become a crisis. One of the 3 computers was completely dead. A second was beginning to fail. Now go back to the voting rule. The spacecraft does whatever 2 of its 3 computers agree on. So think about what it means to have 1 healthy computer and 2 broken ones. The single working computer is outnumbered. It can be completely right, and it doesn't matter, because the system is built to trust the majority, and the majority is now the failures. The 1 sane voice on board could be outvoted by 2 that had lost their minds. A safeguard designed to protect the spacecraft from a single failure had, through sheer attrition, turned into a trap. And it wasn't only the computers. The high-speed transmitter, the part of the spacecraft meant to pour data back to Earth in a rich, fast stream, had developed its own problems. By some accounts, the main antenna had effectively failed, forcing the probe to trickle its findings home at a tiny fraction of the rate it was designed for. The spacecraft had crossed the entire inner solar system and arrived at Mars already wounded, already dying by degrees. And yet, and this is the remarkable thing, it kept working. It still entered orbit around Mars on the 29th of January, 1989. It still turned its instruments on the planet below. It built a thermal map of the Martian surface. It photographed Mars in visible and infrared light. It studied the atmosphere. Its science kept flowing, slowly, through a half-broken transmitter controlled by a brain that was 1 bad day away from being unable to vote itself out of disaster. So, here was the situation by early 1989. A crippled spacecraft, the last hope of an entire program, was circling Mars and slowly closing in on a tiny moon. Its handlers knew it was failing. They knew the clock was against them, and they decided to push forward to the encounter anyway, because the alternative was to have come all that way for nothing. The final close approach was scheduled for the 7th of April. The probe just had to survive a few more weeks and take a few more pictures to get there, so it began to photograph the moon. And the pictures it took as it crept closer are the heart of this entire story. The approach happened in stages, like a camera slowly pulling focus. On the 21st of February, Phobos 2 imaged Phobos from a distance of somewhere between 800 and 1100 kilometers. A week later, on the 28th, it came back for another look, this time from 300 to 400 kilometers, and on the 25th of March, It photographed the moon again, now from less than 300 kilometers away, each pass closer, each image sharper. A potato-shaped little world resolving out of the dark, scarred with craters and strange parallel grooves, swelling larger in the frame. In total, across its short life at Mars, the probe sent home fewer than 40 images of Phobos, some of them resolving features just tens of meters across. For a dying spacecraft trickling data through a damaged transmitter, that was a genuine scientific haul. And then came the 27th of March. On that day, Phobos 2 was scheduled to make another imaging run to turn and face the moon for a fresh series of pictures. And to do that, exactly as it had done before, it had to point its body at Phobos, which meant turning its main antenna away from Earth. You already know what happened next, because we started there. The spacecraft went quiet for the imaging session, as planned. The session ended, and the probe never cleanly came back. 4 hours later, that faint, garbled, indecipherable signal arrived, the signature of a spacecraft tumbling out of control, no longer able to hold itself steady or aim its antenna at home. Engineers worked out what would happen next, and it was grim. A tumbling spacecraft can't keep its solar panels in the light. By early April, the temperature inside Phobos 2 would fall to freezing. By the middle of the month, it would be too cold for any system to function at all. On the 14th of April, 1989, with the probe surely frozen solid in orbit around Mars, the Soviets declared the mission over. But here's the strange part, the part that turned a quiet engineering tragedy into a legend that refuses to die. When investigators later tried to explain what had actually triggered the loss, they could agree on what the spacecraft did. It tumbled, it lost power, it froze. What they could not fully explain was why it started tumbling in the first place. That initial push, the thing that sent the probe into its fatal spin during those few minutes when it had turned away from Earth, remained, in the words of one detailed account, a mystery. Officially, the blame settled, as it had with Phobos 1, on human error somewhere on the ground, but the details were not made public right away. Other explanations circulated. A failure of the attitude control system, a loss of the transmitter, a final breakdown of that ailing flight computer, which had, after all, been showing signs of trouble for months. That last one is generally considered the most likely. But notice the word likely. There has never been a single, public, definitive failure report that closes the case. The probe turned to look at the moon, and it never turned back. And the precise reason is still, decades later, an open question. And into that open question, the stories came rushing in. Because here is where we have to be very careful and very honest about what is fact and what is not. What follows is not a confirmed event. It is a claim. And it comes from one of the most fascinating people in this entire story. Her name was Marina Popovich, and she was, by any measure, an extraordinary woman. She was a Soviet test pilot, one of the best the country ever produced. They called her Madame MiG. In 1964, flying a MiG-21, she became the first Soviet woman to break the sound barrier. Over her career, she set more than 100 aviation world records, flying dozens of different aircraft. She had even, briefly, trained as a cosmonaut, before being turned away after 2 months, while her husband went on to fly into space. She was a genuine pioneer, a colonel, an engineer, a national figure. And after the Soviet Union collapsed, she became something else. She became one of the most prominent voices in the Russian UFO movement. She wrote a book on the subject. She gave lectures and interviews. She made claims that Soviet pilots had logged thousands of unexplained sightings, that the military had recovered the wreckage of crashed objects. And at her public appearances, she would display a photograph. She said it was the last image ever taken by Phobos 2, in the moments before it vanished. And in that image, she said, there was something that should not have been there, an unexplained, elongated, cylindrical shape near the spacecraft. just before the transmission stopped. So what do we actually have? We have a heroic but, by this point, controversial figure presenting an image and a story. We have a spacecraft that really did die, suddenly and never fully explained, while turning to photograph a moon. And we have a public hungry for the idea that the two facts are connected, that the Soviets saw something out there, and that Moscow pulled the plug to keep it quiet. It is a perfect story. The dying probe, the secret photograph, the silenced transmission. And it spread so far and so fast that, decades later, one researcher, trying to find honest technical information about Phobos 2, noted that it had become genuinely difficult because the real mission was buried under an avalanche of UFO speculation. So let's separate the threads. The spacecraft really did photograph something. It photographed Phobos, a real, moving, dark little world, casting a real shadow, crossing in front of Mars. That part is completely true. The probe's final frame really was an image of Phobos, taken from less than 200 kilometers away, resolving details around 30 meters across. That image really is the last thing it ever sent. The claim that the image showed an artificial, cylindrical object that is a claim attached to a particular person with no confirmation behind it. And the claim that Moscow deliberately cut the transmission to hide a discovery runs directly into the most boring and most likely explanation of all. A spacecraft built in half the time it needed, flying on a brain that could no longer outvote its own failures, finally lost its grip during a routine turn. But there is a grain of truth buried inside the conspiracy, and it's worth being honest about it. Moscow did not cut the transmission. The spacecraft died on its own. What Moscow did was something quieter and, in its way, more revealing. It tried, at first, not to explain. When the two failures were finally discussed, in the middle of May 1989, the project's leaders and their international partners gathered at the Space Research Institute in Moscow. And the head of the team that had built the spacecraft stood up and tried to blame the loss on outside forces, on the sort of bad luck no engineer could be held responsible for. According to those present, his arguments were met with open ridicule by the Institute's own scientists, while the foreign partners sat and watched the Soviets argue with each other. It was an uncomfortable, very public moment, because the truth was, by then, hard to hide. The old guard of the Soviet space industry wanted to keep any systemic problems in-house, to present partners and the public with a tidy picture of success, and, where failure couldn't be denied, to pin it on meteoroids or solar radiation. The scientists who had actually flown the mission wanted the opposite. They wanted an honest, public investigation, because they believed the real problems had to be admitted before they could ever be fixed. Researchers on both sides even ran the numbers on whether debris kicked off the Martian surface by ancient impacts could have struck the probe, and found the odds vanishingly small. So when people say Moscow covered something up, they are half right and half wrong. There was no hidden alien photograph, but there was an instinct, deep in the system, to reach for an external villain rather than confront a failure of its own making. The thing being concealed wasn't a secret in the sky, it was a flaw on the ground. There is, however, one detail in this story that is genuinely strange, and it has nothing to do with flying saucers. It's about the moon itself. And to understand it, we have to talk about Phobos. Phobos is not like our moon. It's barely like a moon at all. Our moon is a great round ball, big enough that its own gravity long ago pulled it into a sphere. Phobos is the opposite of that. It's small, only about 22 kilometers across on average, and it's lumpy, irregular, shaped, as nearly everyone who describes it says, like a potato. It is so small, and its gravity so weak, less than 1/1000th of what you feel standing on Earth, that it never had a hope of pulling itself round. A good throw could put a baseball into orbit around it. Jump too hard, and you might never come back down. It races around Mars at a frantic pace, completing a full lap in roughly 7 hours, so fast that, seen from the Martian surface, it crosses the sky in the wrong direction, rising in the west and setting in the east. Its single most dominant feature is a vast crater called Stickney, about 9 kilometers wide, taking up something like half of one face of the moon. Whatever hit Phobos to carve out Stickney very nearly shattered it. Like our own moon, Phobos is tidally locked. It always shows the same face to Mars, never turning its back to the planet. Its surface is scored with long, parallel grooves and chains of small craters, and for years people assumed those grooves radiated out from the Stickney impact. More recent study suggests something stranger and more violent, that at least some of them were carved when material blasted off the surface of Mars itself, by separate impacts, rained sideways onto the moon. Phobos, in other words, may be partly scarred by its own planet, and it has a far smaller sibling, Deimos, only about 12 kilometers across a moon so modest that even Phobos dwarfs it. It's worth pausing on how little we could see of all this in 1989 and how much we can see now. When Phobos 2 died, the sharpest views of the moon were a handful of grainy frames from a dying probe. Today, a rover the size of a car sits on the surface of Mars and films Phobos for science. In 2022, NASA's Perseverance rover pointed its camera up and recorded Phobos sliding across the face of the Sun, a tiny, lumpy eclipse that lasted only about 40 seconds, far shorter than the eclipses our own large moon makes, because Phobos is something like 150 times smaller than the moon you know. The footage is so detailed you can see the bumps and ridges along the moon's edge as it crosses the Sun. Scientists watch these little eclipses carefully, because the precise way Phobos moves reveals how it is slowly falling, how its death spiral is unfolding, year by year. The same moon that swallowed a Soviet spacecraft in silence is now, quietly, one of the best-studied small worlds in the solar system. And Phobos is doomed. It orbits so low and so close that Mars is slowly dragging it down. In the span of tens of millions of years, this little moon is going to spiral in and break apart, or crash into the planet it has circled for so long. We are, in a cosmic sense, watching a slow death. Now here is where it connects back to our story, and to a very old idea. In the 1960s, long before any of this, a brilliant and famous Soviet astrophysicist named Iosif Shklovsky looked at Phobos and noticed something that bothered him. For its size, the moon seemed to be too light, its density seemed too low, and Shklovsky floated a startling thought in the popular press. What if Phobos was so light because it was partly hollow? And if it was hollow, well, nature doesn't usually build hollow moons. Perhaps, he suggested, it was artificial. It was a wild idea, and Shklovsky surely knew it. But it was put forward by a serious scientist, and it stuck. For decades, the notion that Phobos might be hollow, might be artificial, drifted through the culture. And you can see, can't you, how perfectly it set the stage. By the time Phobos 2 fell silent while staring at the moon, there was already a 30-year-old idea floating around that this exact moon might be something more than a rock. So when a strange shape appears in a photograph of Phobos, the ground is already prepared. There's even a real physical object on Phobos that keeps this story alive. It's called the Phobos monolith, a single large boulder, roughly 85 meters across, standing near the edge of Stickney crater, casting a long, sharp shadow. It looks, in low-resolution images, oddly upright and out of place. People have called it building-sized. The astronaut Buzz Aldrin, the second man to walk on the moon, has publicly wondered aloud about who or what put it there and argued that we should go and look. And here, finally, science has a calm, clear answer. The most likely explanation for the monolith isn't mysterious at all. When something smashed into Phobos hard enough to blast out Stickney crater, it would have flung enormous boulders across the surface. The monolith is almost certainly one of them, a chunk of ejecta, thrown by an ancient impact, frozen in place on a low-gravity world. It looks strange partly because our cameras can't quite resolve it, and a blurry rock often reads to the human eye as something far too regular to be natural. In other words, the things people point to as evidence of design on Phobos tend to dissolve, on closer inspection, into the ordinary, violent, beautiful physics of a battered little moon. But there's a final twist, and this is the honest, genuine mystery that survives all the debunking. Shklovsky noticed Phobos was too light. He was wrong about why, but he wasn't wrong about the lightness. Modern measurements confirm that Phobos really is less dense than a solid lump of rock should be, not because it's hollow and artificial, but, most likely, because it isn't fully solid at all. It may be a loose, porous pile of rubble, full of empty space, held together by the faintest of gravity. And we still cannot say for certain where it came from. Some scientists think Phobos and Deimos are asteroids that wandered too close to Mars and got captured. Others think they were born from a colossal impact made of debris blasted off Mars itself in the deep past. We don't know. After all these years, we still don't know what the moons of Mars actually are. And one more thing the data does tell us, almost as a footnote, the instruments on Phobos 2 before the end, searched Phobos for any sign of water. They found none. So that is the real story behind the title. A spacecraft photographed a moving object near Mars, and the moving object was a moon. An ancient, doomed, mysterious moon, photographed by a dying machine in its final minutes. The transmission wasn't cut by Moscow to hide a secret. It was cut by a typo's cousin by haste, by failing computers, by the long shadow of a project given half the time it needed. The mystery isn't what the probe saw. The mystery is the moon itself, and the silence it left behind. What happened after is its own quiet tragedy. Phobos 2 was the last interplanetary probe the Soviet Union ever designed, and the system that built it didn't last much longer than the spacecraft did. Within 2 years, the Soviet Union collapsed, and the funding for planetary exploration collapsed with it. The Soviets tried to fly the same design again, on a mission called Mars 96, and its rocket failed, and it fell back to Earth. Russia tried once more, decades later, with a probe called Phobos Grunt, aimed at the very same moon, and it failed too, stranded in Earth orbit in 2011. Add it all up, and you reach a sentence that sounds almost impossible in the 21st century. To this day, there has never been a completely successful mission to Phobos. We have flown past it, photographed it, mapped its craters, even filmed it from the Martian surface drifting across the face of the sun. But we have never landed on it. We have never held a piece of it. The little moon that the Soviets crossed the solar system to touch has stayed, stubbornly, just out of reach. There is a final image worth sitting with. Among the last frames Phobos 2 sent home, before the silence, was a single picture of the moon taken from less than 200 kilometers away, sharp enough to pick out the strange grooves carved into its surface. The team that built the spacecraft processed it, sharpened it, studied it, and then they wrote, simply, that this was the last image from the probe. No grand statement, just a note that the pictures stopped here. For 35 years, that has been the high watermark. A frozen spacecraft, a final frame, an open question about how it died, and a much older open question about what the moon even is. But the story is not quite finished. Right now, on the other side of the world, another spacecraft is being readied, this time by Japan, with help from agencies in the United States, France, Germany, and Europe. Its mission is the one the Soviets dreamed of and never completed: to fly to Phobos, to land on it, to scrape up a few grams of that ancient surface, and to carry them home. The probe has already arrived at its launch site. It is waiting, now, for its window to Mars. And if everything holds, sometime in the next several years, a small capsule will fall through Earth's atmosphere carrying the first piece of Phobos that human hands have ever touched. Then, perhaps, we'll finally know whether it's a captured asteroid, or the shattered child of Mars, or something we haven't thought of yet. Then, the lightness Shklovsky puzzled over and the silence Phobos 2 left behind will start to make sense. Until then, the moon keeps its secret. It keeps racing around Mars every 7 hours, casting its long shadow, falling imperceptibly toward the planet that will one day end it. And somewhere up there, still in orbit, frozen and silent for over 3 decades, is a small Soviet machine that crossed an entire solar system to look at it and got close enough, in the very last moment, to see the grooves on its surface. Before whatever happened, and it turned away from us for good. We built the probe. We aimed it across 400 million kilometers of empty space. We watched it reach the one small, strange world it was sent to find. And then, at the exact instant it turned to look, we lost it, and the dark closed back over the moon, and we were left exactly where we have always been, standing on one planet, staring at another, holding a blurry photograph, and realizing how little we actually know about the small worlds right next door.